Hello everyone and welcome to today's live stream where I'm going to be using an experimental branch of Blender 4.3. So this probably won't be in Blender 4.3 when it comes out in like 6 months or something like that, but it's an experimental branch where one of the developers has added rigid body physics, kind of ported the bullet solver into this one. I'm just going to check the stream health for a quick second. Yeah, all that should be fine. The preview is being just a little bit funky, so I might just refresh the page right there to make sure that it's fully running. Still acting weird. No, it should. Okay, it's good. Sorry about that. But yeah, this is the setup. I'm kind of just experimenting with it and seeing what actually works and what doesn't. Because in this case, I'm really hacking this together. Apparently you're not supposed to join more rigid bodies into the scene just because of the way it works right now, but I decided to try it anyway just because I really like to just, I don't know, see what it's like to procedurally add rigid bodies to a scene like this. And so let me explain the setup. So once you have the test branch, if you have it installed correctly, let me also just go and delete some of this stuff to make it a little clearer. This is a mess. I apologize. Let me try to make it a slight bit better. So maybe I should start from scratch and then show you how to build up from there. But if you have the branch in the simulation tab, again, this branch just came out today. They've been working on this for about 2 months, but the branch has just become semi-public today. So, with in the simulation tab, you have the simulation zone, and then you have a lot of nodes. Do I know what all these do? No. Like, some of them I kind of know what they do, like all the forces, the time step, and all that. Constraints I really want to play around with, because that would be very interesting. But yeah, this setup is a bit iffy, so I probably should restart from scratch, or I'll just simplify it so that it'll have a set amount of points, so that we don't need to worry about too much else. Yeah, that sounds good to me. Okay, so let me tone this down by a bit so that it'll just be normal. Okay, so we need... Oof. Yeah, I did not consider how bad this is going to be. Yeah, let's switch this for just 2 box things. Okay, let me move this around. And I assume that this will be a lot simpler when it actually releases. Right now, again, I just assume that this is very primitive because, again, this branch is very new. But yeah, okay, let me just delete that, delete everything that's unnecessary, and delete you as well. Okay, so again, this branch is very, very prone to things breaking very often, and crashes have been very frequent if I try adding torques or forces or anything like that. Okay, so how does this work? Well, with this scene, it's a little bit weird and a little bit, you know, just a little bit quirky. So, what you have are a kind of new class of objects, or another component of geometry inside of geometry nodes. And again, this probably won't be in 4.3, just gonna lay that out here. This is an experimental branch to see how it works. But there are these new things called bodies and constraints in the physics little tab right here. You can see all the data in here. It's not fully integrated because you cannot find these attributes in the stored named attribute node, as I should probably showcase here. If we look here, let's let the cache play a little bit. We cannot find them in here, even though technically the bodies are in the point domain, and then the constraints are in the edge domain, as I saw in the little bit of documentation. But anyway, just to explain why... Oh, the frame, that explains why. Okay, let's bring this back over to here and take a look at that. So what we do first is we use the points to rigid bodies node. We have a ton of points right here. Let me reconnect that and set like, let's do 50 points. So we put the points into here, and then we assign them a shape, and then we can give them like angular velocity and all that stuff. And then I also put in a static plane using the points to rigid bodies. Like in the version that I tried making, in only geometry nodes, no code, like no proper C++ coding whatsoever, my rigid body physics objects were all instances that on the the instance would be a point when like forces would be applied, but then it would reference the instance geometry when it would go and try to get the collisions. In this case, it works somewhat similarly, but a bit differently. It's it's interesting. Because here, it's kind of like the instance on points node, I guess a little bit, very little, like it's very, very different under the hood. But here we have a point, and then we assign it a collision shape mesh, which when you put in there, probably stores the inertia tensor and all that fun stuff, even though it has a vector inertia tab, which I should look into the code. That probably would be very good to look into. But then, by default, I think the bodies are dynamic, which in this case I just set the plane to static, and this one I just gave it a box. The box collision shape here is the same as what gets instanced later on, which I should also mention again. You just cannot see what's going on until after you put in the instances and then put them into here. So, would it be better if the stuff was, like, if you could see the collision convex holes or, you know, just the collision shapes in here? Maybe, but I'm not sure how that would work, because some are not meshes. In this case, there's a lot of stuff that you can do that is not a mesh. Triangle meshes and convex holes are available, but again, it's very interesting. But yeah, but once you do that, you put it into the physics world, which you can assign the gravity here. I'm not entirely sure what this node does, other than, you know, make sure that gravity happens. I'm assuming that... Yeah, I just don't know how it works, because what kind of geometry would that be? But this is what I saw in the photo examples, so that's what I am running with. And then you join, you know, the bodies together with that, and then you put that into here, and then it's just the physics time step. This handles the collisions and all that. I have not found a way, and I'm not sure if this is even implemented at the moment. Again, this is very, very basic, very, very, like, just lots of beginner stuff. Okay, let me go and take a look at all this once again. Let me going up this to, like, yeah, let's do quite a few more. And I need to make sure... Okay, I did break something, and I will try to... Oh, that's why I broke. Okay, index. Sorry for not explaining all this in full. Let's see, index. Let's put that into there. So after you have the rigid body bodies, because they're a special type of geometry, output there, you then transfer that data to the instances or whatever you want. So yeah, you could just sample it. You want to sample from the point domain, and then you can just go and put that on and into there. Again, the data in this case is on the point domain for the rigid bodies and the edge domain for the constraints. I do not know how the constraints work, because when I try, it crashes. But yeah. So here, as we can see, we have a ton of cubes, and they just kind of work. In this case, the cube that I'm instancing, using an instance on points node, matches the box dimensions. I don't know how to make a custom, like, have a convex hole or something for each object in a collection without, say, using a repeat zone. I'm assuming that maybe that's just not implemented at this time. But yeah, so it's a taste of what could be in the future, which I'm very, very interested in. This could be very cool. Let me up this to 500. This will lag a bit. But we get that classic rigid body physics effect, which is really, really cool. Just like that. And we can have some different objects working, like over here I can swap out the cube with any kinds of objects, but I just need to have another piece of spaghetti going over here. So here I'll switch this to be a convex hull, and I'll go and put a mesh into there, and also have a line of geometry going to the instance on points node. Again, this is very inconvenient, but again, this is experimental. This is not in Blender 4.3 in an official capacity. It's an experimental branch. Here we can see that this is very, very laggy. I'm assuming just because, you know, it's a lot of monkeys and all that. Lots of rigid bodies interacting. Again, like, no GPU acceleration, it's all on the CPU, because geometry nodes is all on the CPU at this time. Yeah, we can see that the rigid body physics work and are much more stable than mine. This is infinitely better than the version I tried making, mostly because, well, it's Bullet. It's using the Bullet physics library. while me trying to recreate all the stuff from scratch with help is a very daunting task for someone who never took a day of college-level math in my life. But yeah, let me go back to a simpler object, because this is lagging just, just a bit. But it's interesting how this is doing stuff that we just can't do in geometry nodes, as far as I'm aware. At least not without great difficulty. Ooh, that is, wow, why is that lagging so much? I was not lagging that much when I was testing with the off-stream. Maybe it's just too much here. Let's go and do this much. There we go. Ton of cheese wheels. Very nice. But we can see how solid it is, and I want to kind of dissect it and see how certain parts of it work, like the contact points and all that. But with this, it does stuff that I could not do in the geometry nodes version, which is like pairing up the objects for the collision points and all that, doing that for every single one that is being contacted. Well, I guess technically you could, but it would be so inefficient that it would lag with probably like 3 objects. But, so, with all this, what's it useful for? Well, I guess when if and when it becomes fully integrated, maybe I could have like a robot creature and then have the objects moving normally, but then when they get hit by, say, a raycast or something like that, they get knocked off and then fall to the ground, like the Horizon games. That's something that I've been trying to do for a while, like having either objects or a procedural creature walking around and then having physics actually affect it. Maybe setting up a procedural building generator and then having the buildings fracture and all that cool stuff, because we can set up, in the old rigid by physics system, setting up constraints was a big pain. And doing anything with mass amounts of objects was very difficult as well, because you had to keep updating, all the objects. But here we can just say, oh, we want all of these in a whatever assortment we want, and then just hit play, and then they just fall, which is really cool. If you're wondering why these are floating a little bit, I'm just going to assume that the floor plane is not exactly one-to-one. Again, in this case, since it's a bit difficult to go and assign, or I haven't figured it out, assigning shapes to objects easily, right now the plane is just virtual, and then I put a mesh in there by default. But this is the future of physics in Blender. Because, again, in the old version, in the old rigid by physics system, in 2.8, all of that broke. Because apparently it was not a good system beforehand with the dependency graph, and in the new dependency graph, all of these just haven't been updated. Which 2.8 came out around almost 5 years ago at this point, so we've been 5 years with a broken rigid body physics system. But this seems like it could be the solution, which, again, this is an experimental branch, first day. Don't set your expectations to be too high, but after trying to make my own, and then seeing that all this just work, almost seamlessly, there are still crashes. It's rather easy to get excited with all this fun stuff. So what else could we use? What else could we put in here? Let's take a look at some mesh primitives. Let's see, well, that's kind of plain. What other objects do I have? I do not have the extra objects add-on enabled, because I think because of the extensions, I would need to download that from the internet, or then, regularly download that. But maybe, yeah, let's try a few toruses. Also, I guess that this, I don't know. Let's try this out. Let's see how that looks. There we go. Kind of looks like Sonic's rings when they fall. But yeah, cool stuff. And I've seen some parts in the documentation, or not documentation, in the dev talk post, that potentially the contact points may be output as a kind of geometry thing, which could be very cool. Like when an object hits, maybe making sparks fly out, sending that over to another geometry system. That could be very, very cool. One thing that I'm very interested in is, with this, all of these objects are on one piece of geometry. So if you have, say, a collection and you want rigid body physics to happen on them, in the old version, it would move the objects and just do that. In this new version, they would all have to be combined into one geometry node in order to make it work, since we don't have, like, scene collections or something like that. And I guess the dependency graph would have a lot of issues with that as well. So it will be different. It won't be a complete one-to-one replacement of the old geometry node system, or old rigid body physics system, because it would be like one object having a lot of rigid body objects that are in either another collection or something else. And then assignments to those rigid body objects, I would assume... Yeah, how would that work? I guess you may need to assign some stuff to the object. Like, if you have an object over here and you want to say, hey, this object is static, you need to assign that. Kind of like how you do it in here, you say, oh, like... Oh yeah, I guess a lot of stuff is pretty similar to what is over here already. Like setting it to active and passive, and then doing that, and then referencing that in another piece of geometry. Because right now, all has to be done under the hood. But again, I'm talking about stuff that will probably be like a year out. I didn't expect rigid body physics, like a branch, to be out this soon, like one that, you know, actually uses the simulation zone. Because I think 2 years ago there was another rigid body physics experiment, but it was using, since simulation nodes didn't exist back then, they were just using like an inbuilt system for that. But actually seeing it actually use the actual caching and all that, and with the hopefully the new caching systems coming in the future, or controls and all that, maybe we can have some really, really cool stuff coming later. But, with all that said, there are a few things that I kind of want to try. Because, with one thing, if we look at this from the top, you know that one classic example where a ton of particles or something fall, and then they lay out into a perfect image. Well, how would you do that in this system? You couldn't, I don't think you could, maybe you could make that in the old system. I'm actually not sure. And if you could, I would assume that it's very hacky. But anyway, in this new system, I'm assuming that you could use a bake node. So just going over here, bake. You could have the rigid body physics system go out to a certain frame, and then you can say, bake that output, just like this. And then connect that into there, and then that's frozen. So then you can store, say, a position data, or whatever that is, and then port it back to the object as a kind of UV coordinate back in time, which could be very cool. Which, I guess I could showcase that a little bit now, even though it would be a bit hacky, but what else is new? What else is new? So I could just have that, and then just have a different geometry stream. This one's up here, this one's over there. Then I just go and store a named attribute on the, yeah, vector, instance, yeah, there we go, instance. So we store this in this will be P1 for position 1. So just with that little addition here, which again, this stuff is very, it's not exactly convenient, because again, you have to go through a lot of hoops, and I'm not even sure if this is the correct way to put the rigid body data onto instances, because there was not an image of that, so I was just like, it's on the point domain, so even though it doesn't technically show up correctly, I could go and put in position on the named attribute, and then port that over to there. Is the plan to eventually replace all physics and geometry nodes like cloth, fluid, rigid body, soft body? Yes, that's what I've heard. We're a long way off from that happening, but I'm very happy that this version exists, because it's a foot in the door for something happening, which I'm very happy about. Because apparently, like, again, from what I heard, this was in the works for about 2 months on and off. And then, yeah, so putting the bullet physics code, and I don't know how much it was customized. I'm assuming it took quite a bit of work in order to port the stuff and make it compatible with geometry nodes. But that, and then all of that, the actual physics parts, gets condensed into just this. Which you could add in the force, apply force and torque nodes and all that into there, but at the moment it crashes if you update it not on the first frame, so I'm not going to do that because I like having Blender open on these streams. But yeah, one other thing is that the points to rigid body node is technically not in this part, which is a little odd. I'm not sure if it's actually in here. Is it in? Oh no, it is to here. There's points to SDF grid. Since when was this the points to volume node? No, okay, that's different. Oh wait, are the volumes actually merged in this version? Wait. Oh, they are. Huh. I didn't know that. These were an experimental thing in 4.2 and I think 4.1, and maybe even 4.0. They've been in the works for a while. But these, the dev said, may potentially be the building blocks for something like fluid simulations in the future. Not this one, just the ones in here, like getting the grid index, sample grid index, all that kind of stuff, which would be very, very cool. I may look into that if I have a lot of time on my hands in the future, which by the time 4.3 comes out, I might. The bake node approach does not seem convenient, to be honest. Well, I would say it's convenient if you want to change it up, because you let it play, and then you can just clear it, and then click that button, and then boom, you have that. So, again, even in this basic version, a one-click solution could be cool. And the only part that I think would be the least convenient part is that in Blender's UI, these buttons cannot be put into a node group. Because with this, if I could just make it into a node group and then it just runs, that would be very cool. Like with this, I could just go and say, hey, if you're a node group now, go run. That would be very, very good. But unfortunately, the UI stuff for baking and all that, we just don't have access to. Stuff like enums, like these ones, we just can't do. You just can't output them to the UI. The devs have mentioned that they want to update that, but apparently it would need a lot of work, so I would not expect in 4.3, or who knows? Who knows? But yeah. Oh, so yes, what I was doing right here. So let's go and get that data over to here. So attribute, we can just go and take a look at this on the instance domain. We should see over in here that this data should be the same. And then when we go to here, whatever frame it lands on, we should see that it's laid out correctly. Or is it? Let's go and delete the bake and bake it again. There we go. Okay, so a little bit later. Now, when they fall, they will eventually go back to that position because, again, it's just the baked one, which is really, really good. Okay, yeah, contact points with force. Sorry for not reading the chat, I've been pretty absorbed into this. Contact points with force data would be amazing. Unity and Unreal has that, and it's great for VFX. Yes, that would be very good. And also, the big thing with my version, my geometry nodes only version, like no coding, what I was very tripped up on was how do you get the collision, like how many collision points are there per object? Because when it's like, oh, two meshes intersecting, do you have like 1 point per face, or do you have 1 point per object for efficiency's sake? And how do you accumulate those forces together in order for it to actually affect the body? Because the part that I found that semi-worked was the mean, when it probably should have been summed, but when I summed it, it would just increase way too much, because, obviously. I think I didn't take the mass correctly into account, but that's a story for another time that I need to look into. And then, the same thing happened for, like, when you need to move the mesh out from the center. I used the mean for that because, technically, you want to get the furthest point inside, like, the max penetration depth, and then move it out by that amount. But I had some trouble with that because, well, I could have used that. I did try out the attribute statistic node, but that would not work for multiple objects. It was a bit of a hassle. Blender, at the moment, I think because we don't have a for each loop, I'm not sure what they use in there. I'm assuming a for each loop for each body. It goes and gets the collision shape, and then for each thing it goes through, sees where each one collides and all that fun stuff. But I'm not entirely sure. Let's see. I think you can just store the attribute at frame 20 or whatever. Why not use this approach? Because the data has to be pulled back in time. So here, you need to bake it because it's like, oh, you're pulling something from the future. You run the simulation to a certain frame, you bake it, and then you rewind time. So this data, if I did not use the bake node, would just not be available because it doesn't exist yet. It only works because we're breaking the laws of physics, in a way. Well, we're breaking the real-life laws of physics just to say, okay, that's where they're gonna end up. Rewind. The main problem I think I have is that if it never gets GPU support, then it will be useless compared to external software. Well, that's the thing. CPU, like Blender is very CPU heavy, everything is CPU based by default in most cases. But the CPU is really good for big productions because with GPUs you usually run into limits with like the VRAM and all that. So even if Blender was... if geometry nodes is CPU limited, it would still be useful, but for hobbyists and, well, people like me who use this for like small experiments again and again for learning, it will just be slower. But again, with rigid biophysics, even in the past, well, no. If it can do more, then we can do... I know Cinema 4D has a GPU accelerated rigid biophysics, which I am very envious of. But where geometry nodes is not there yet. And apparently, one of the... I think the community devs was talking about it. Not all nodes in geometry nodes can be GPU accelerated, which... that makes sense for things like, I guess, probably extrude and stuff like that, that edit the geometry. You can't really parallelize that well. When you're moving like a million points, that the GPU would probably work very well with, because, again, tons of points, tons of raycasts, all that. There's a ton of something doing a lot of something very small, and that's where the GPU is really, really good. I think in this case, the GPU, well... I don't know how the internals work. Again, Bullet is fairly old, so I don't know if it would be even compatible with that. But GPU-accelerated rigid biophysics systems do exist, but they're still rather new. GPU-accelerated smoke and fluid simulations, those are... I wouldn't say fairly new. They're like... I don't know, EmberGen is how old? Like 7 years, maybe more? Or since the betas. I forgot when I... well, I know it was like pre-2020, I forget. But stuff like that probably could be GPU accelerated in geometry nodes, but I'm not sure. Again, that's all a technical thing. I do know that the devs have put in a good amount of work to parallelizing stuff, so that's very fast, multi-threading the nodes. In 4.2 alone, the sample UV surface node got a speed increase by a very big amount, I think by 10 to 20 times on large meshes, which I assume is due to parallelization and stuff like that, and optimizing all that fun stuff. I'm not going to pretend like I know how all that works. Again, I am just a tourist coder. I do it when I need to, and nothing more. Because I like notes, I like the lines and boxes. It's most expensive to pipe data back and forth between the GPU and the CPU. It's hard to make the procedural geometry code run on the GPU. They are at odds. Yeah, like with the one modifier that does sometimes use the GPU, which is the subdivision surface node in the experimental and cycles. I forget. Experimental, I forget which one. Ah, here we go. Well, yeah, I'm not sure if adaptive subdivision uses that. But in some cases, the subdivision surface node, because it uses OpenSubdiv, sometimes uses GPU acceleration, but it has to be last in the stack. It'll give you an error if it's not. Because when you feed data from the GPU back to the CPU, that has quite a bit of delay. And that would make things very slow. So if you did run a rigid biophysics simulation on the GPU, you would have to go and bake all that out before it can be used by the CPU. You would have to just store the data, which may or may not be good. But I'm assuming if something like Cinema 4D uses it, it's probably useful enough. But yeah. Apparently, there's more data stored in here besides just the vertices and edges for the constraints and the rigid bodies, because apparently for the collision detection, like the pairs that are needed, there's some data that needs to be cached for the next frame. I saw a little bit of that in the dev talk page, not documentation. I need to stop saying that. But yeah, I could move this back here and make it a lot cleaner. But no, I should leave that over there. But yeah, there's a lot of stuff that could possibly be done. Again, this is the first implementation, but I want to see where it goes because it could be very, very cool. Let me put another cube in here. But yeah. And also, like, I really wish I could go and make some... I was experimenting with some effects using the force and torque nodes, which... Yeah, I'm gonna try it. If it crashes, it crashes. But I should be completely fine if I just stay on frame 0, which is before the calculations happen. Because apparently, I think if you cause an update when the simulation is kind of running, it just crashes. So if I were to move that empty by myself when it's on a frame other than 0, it'll crash. So let's go and subtract it there from there. So this will put a force from the position to the empty. So let's set that to like -5. Probably should use some delta time. Oh no, that was reversed. So let me flip that around, put it up here. There we go. So if we do this, we can see that they're all attracted to the part right there, which I think that was definitely possible in the old system, right? Force fields. Oh, wait, no, that's something that I meant to mention. Force fields. Another thing where in geometry nodes we just can't access the data for, which I think could be very useful. Because with, like, either as, like, a node where it's like, okay, all the forces in the scene, evaluate all of them, put them together, and port them into the, as, like, a force vector or data or something like that. Rather than recreating all of these forces inside geometry nodes, maybe just have a node where you can access that data. That could be good. And would probably be way more efficient than having to use a repeat zone and then going through all the empties locations and then trying to approximate it. But yeah, I don't think these work at the moment, and I'm very, very afraid of trying to use them. I am curious. So let's just... There's no way that this works. There's no way it's integrated. No way, but let's try it. Yeah, no, it's not working. Okay. But yeah, it's a cool first look into this. I probably will end the stream very soon because I don't want to delay this any more than I have to. It's just a short stream showcasing something that's pretty cool. And again, if you want to take a look at the nodes I have currently right here, just to do an overview, you have the points, which will be what the rigid bodies are on, and then you have the actual shape of the object. Currently, I don't know how to do one for every single object in a collection or something like that. You make the points to rigid bodies similarly to how you instance on points, but, you know, it's different. So you have this, you set it to a convex hull or whatever you want. You could use a triangle mesh, but for speed, convex hull. Then you set all that. For the ground plane, this is just the setup for that. You put that into there, which I guess technically means that the sample index node is not working properly. No, that's last. Okay, no, but that's fine. And then you can join that with the physics world, which I still don't know what that does. Maybe it just ports some special data into there. But then you put it through the simulation and all that, and then you can do all this. This crashes very often, so proceed with caution. And then over here, well, just ignore that. This ports the rotation and position data from the point domain, which is what the rigid body physics uses, and then it puts it onto the instance. And then for the instance, I just took the same amount of points and instanced the cube onto there instead of like the convex hull. So it's kind of doing two parallel processes, which if you were to make this into a node group, you would probably just have it do that under the hood. And then, you know, that just works. So again, you could just... And it crashed because I caused an update right when that happened. Let me get that back up and running. Sorry, everyone. Be right back. I knew the rules and I broke them. But let's go back to square one. Actually, no, that's a bad idea. Okay, I'm gonna go and recover the autosave. There we go. Okay, we're back. 1 second. Toggle window full screen. Here we go. Okay. So here, once again, all that stuff's happening, but I'm going to disable that node so that we don't get any more crashes at this time. Wait, what if I know I can edit the data. What happens if I try that? Because I haven't tried affecting it directly yet. This is probably a terrible, terrible idea, but I want to try it. So if I just say that the position is locked, no, that is a horrible idea. Just in case, I'm going to make it so that it's random per body. So here, oh, another quirk that I found is that the ID will not work. So you need to manually put the index into there. So here we can see that part is functioning. I think that's just a quirk of... Okay, that's interesting. So I can technically... I can parent these manually. I can kind of make my own constraints, I guess. But it won't affect the torque and the... Oh yeah, I should showcase the actual data that's being put into here. So... let's lower this to just 1 or 2 so that we can see all of it. Here, let's take a look. Okay, so we have two bodies. One is the static and one is the dynamic. We can see that they're... I forgot the hotkey for zooming in. Just full screen. There's spinning friction, and then... Actually, yeah, I haven't seen that in any of the physics papers I've looked into, only static and dynamic friction. There's the rotation data, the activation state, which I'm not sure what that does. Static, you know, just a Boolean value. Restitution, which you can't affect it, but I guess I'll need to set that manually using a stored named attribute node. That affects how much it bounces. The inertia, which I assume is just the inertia tensor. But it has 3 values, which makes me wonder if internally... it's using the rotation, because I was always wondering about that with the inertia tensor. Like, it's a scale, but it's a scale and a rotation. So, for efficiency's sake, do they just take a vector scale, and then take a rotation data, like a quaternion or something like that, and then combine them while the calculation is happening? I don't know. But I wonder if that is the accurate data, or if no, I'm using, yeah, I'm using a convex hull in this situation, so yeah, maybe that is it. I'm not sure. ID, I'm assuming that's just, I guess, for instancing later, maybe, I'm not sure. Mass, 1's 1, 1's 0, if it's static, the mass will be 0. The position, the linear sleeping threshold, which oh, if an object is not moving a lot, it will just be put to sleep. Again, I think bullet was used in games, but I'm actually not sure about that. Angular dampening, angular sleeping threshold. Oh, that's interesting. Velocity kinematic. Oh, wait, those are both off. I need to look into what kinematic means. Huh. Total force, angular velocity. Because with all the forces, you stack them all up, just add them all together. Angular velocities like that. There's no angular momentum stored, which is interesting. Huh. Well, I'm assuming it's stored under the hood because you need that for the inertia tensor. I'm wondering if that's... Actually, wait, where's... Oh, total torque. So maybe they just have the torque and then apply the inertia tensor and then they derive the... Angular momentum from the velocity? I'm actually not, wait. They have the center mass here, which is a 4x4 matrix, but it's only using the outside part. So maybe that is just a position? Or maybe because I'm using a regular object, it's very regular. So let's try something that is irregular, like the monkey head. There we go. Plug that into there, and let's just take a little look. Center of mass. Ah, yes, that is very... Okay. Okay, that makes sense. So maybe that is just the inertia tensor right there, with position data for the center of mass. Because that does make sense. That does make sense. Huh. I never thought about it that way. I never thought about doing that, but that makes a lot of sense. So it's 0, 0, 0. Makes sense. And then that one at the end. I don't know what that one value does. I should look into that. Then rolling friction. Oh wait, is that just static and dynamic friction, but named something different? Spinning friction and then rolling friction. Yeah, I don't know. But it is... Oh, and then there's just regular old friction, which is defaulted to 0.5. Okay, so linear dampening... Oh, those are all the default values. So, if I do want to set the friction values to be something different, I can just use a stored named attribute node on the point domain, because these things are just a little bit interesting. So let's do restitution, spell it right, set it to float because that would probably crash instantly. But we should see on this side, where are objects? Oh, I'm still setting the position to be 0. Okay. Let me just go and disable that real quick. We should see... you okay, buddy? Ah, there we go. Okay. We can see now it is bouncing. So if we were to set that to be 1, we would see that it would bounce a lot more. And sorry for not reading the chat. I'll read that real quick. Oh, but since the restitution of this one is 0, that means that it'll be like 0.5, but if we have both those be 1, we should see, yep, there we go, bouncing. So even though the rigid body physics system that I made with help may not be, will probably not be the version I'll be using going forward if the devs continue to work on this, I'm very happy that I did do it because it was such an educational experience, seeing like all the equations and actually making a physics setup that actually uses the correct algorithms. Because before I would very much wing the bounce and the friction just using like project and reflect nodes, which might be okay. I'm still not sure about that part. But seeing the actual equations and working with them is much better. But yeah, it's cool to see something that just works, in the famous words of Todd Howard. And all this is working in one step, which is very interesting, because Blender's rigid body physics system needed quite a few more steps, which I'm actually very curious as to why now. But if you do want to have more steps, you could always have like a repeat zone and just divide the delta time by the amount of steps. So, technically, in a way, substeps can be done in simulation nodes, but they won't be great when dealing with objects that are accessed externally. Those will still be limited to a certain the manual frame rate, unless you do some really fancy stuff that I really don't want to do. Okay. What else could I do? What other fancy stuff could I look into? And if you're wondering, oh, why don't you just instance on points? I did try that, but I will try that again to see if it would just work. Because as we can see here now, it doesn't show up, because technically it's not... Even though it uses the points domain, I have a feeling that that's a placeholder. Because, yeah, like it's technically a point because points are just one thing. I guess edges are used because it connects two things together. What would be cool, like, some people, I think the developer did mention that they would like to visualize some of the data, which it would be very cool to have kind of visualization tools to see all the connecting bits. But yeah, that could be very cool. Like, even in the most primitive state, there's a lot of cool stuff that I would like to do with this. Because again, tons of bouncing cubes. Like, the convenience of just being able to say, I want some more cubes for something if you have just a simple procedural project, if you have like a ton of, I don't know, donuts falling down or dominoes, Jenga towers, all that kind of stuff. Just have a procedural Jenga tower, then just build it up, send it over to the system, and then it'll just crumble. Like that is very good. That's something that I've been wanting for quite a while. And then like maybe procedurally fracturing a wall, which we can now do in geometry nodes thanks to node groups that people much smarter than me have created. And then once, like, say, I figure out how to make a convex hull for every single shape, you just port it into there, and then that, and then it would work. And then setting up constraints procedurally would be very cool. That is the future that I would like. Okay, so what other points could I do? I guess I could... Let's see, let's get a grid, and I could convert these 2 points. Actually, do I even need... Out of curiosity, do I even need a point cloud? Or could I... No, it looks like I need to use an actual point cloud for that. Yeah, okay, I need to use a point cloud. Okie dokie, nothing too bad right there. If we just do that, boom, instant grid. Let's use a transform geometry node to, let's rotate it on its side and then move it all the way up. So here we can see instant wall. That apparently the rigid body physics has a bit of a... Oh no, wait, that's because I stored... Yeah, I stored some random angular velocity. But right here, again, like look at that. My system, or the system I was working on, would only handle one object because I was trying to get the math right. But I don't think geometry nodes, just by itself, without some, you know, code help, would be able to do all this in real time. That's cool to see. Let me read the chat once again, because I've been neglecting that. So will we need to check if there are nodes which do not support GPU and use GPU or CPU rigid body? In the future, if that becomes a thing, maybe. I mean, it would probably give you a warning saying, "Oh, this would not, this does not use the GPU" or something like that. But again, that's far, far, far in the future, if it comes out. If again, there are very loose plans that I've heard from the devs, but well, very mentions of GPU acceleration, but nothing concrete. Yeah, look at that. Something so convenient. Like once you have it set up, and once the nodes improve and become better, just that, and then boom, you have a wall of cubes, and they just fall. So nice. Won't it be faster to calculate physics on the GPU and then bake it for CPU rather than simulating it all on the CPU? Probably. I assume that's what Cinema 4D does. Probably rigid body is just a point that contains gravity vector or something like this. Oh, it contains a lot. It contains a lot. What I'm most curious about is this node right here. Because it's just a little bit weird how this is a physics world with gravity. And then without that, there is no gravity. But I'm assuming that, like, if I were to connect the angular velocity, everything else would oh! Well, now I am very weirded out by this. Interesting. I'm not sure which parts of this are because this is a very early branch, or if it's just the way rigid body physics work. But having to join that into a physics world. Maybe I'm just completely blindly speculating here. Components... Like the separate components node, maybe it's something like that, where... Oh, physics! Oh, I didn't even... Wait. I didn't even see that. So here it'll separate the physics component. So maybe that joining that to that just says, hey, there's a physics scene in here, and then it joins into there. I am not sure about that. There's not a combine components node. You just use the join geometry node for that. So I'm assuming that's what that's kind of doing. But again, not sure at all. I should look into the code. But yeah, cool stuff. Okay, we're almost at 50 minutes, so yeah, let's wrap this up. So, oh wait, I can affect the... I can technically. So here, if we take a look at that, yeah, okay, yep, that's the data. But I could just go and look at that. So yeah, you can separate all the physics parts. Okay, so I guess technically, maybe, I need to see if this crashes, but maybe I can affect the total torque and the total force with the named attribute, and maybe that won't make it crash. Oh no, that's a bad idea. So let's just put in total, the total, force. I would probably need a named attribute of the same thing so that I increment it, because I don't want it to override, like, the, whatever. Actually, wait a second. Let me take a look at this normally. So I'll just pass this along and then take a... Oh, shoot. And then I could just... Yeah, there we go. Okay. So we take a look at that. Let's take a look at the total torque. So even though those are falling... Oh. Okay. So even though those are falling and all that, the total torque doesn't do that, because I assume that all the collisions are just handled under the hood. So let me just see. Okay, so they are doing stuff. They are moving in a more interesting fashion. So if I were to, let's see, will that... Oh, that doesn't crash. Oh, lovely. So great, a workaround already for that kind of crashing. And then I really want to see, if I can figure out how to add constraints and all that, how I can go and warp those and what data is stored, because that could be very, very, very cool. Because I'll just showcase this really quick. Constraint, physics constraints. I assumed I would just join that into the fold and then stuff happens. But it also shows physics like that, so maybe... Or, wait, I saw in one of the examples that it needs to be combined into there. I don't know, I'm just gonna put you right here. And then I'll go and see what's going on. Yeah, I don't know what this does. I just don't. Constraint. Oh, wait, and I need to take a look at the output. There. Wait, why? Oh, viewer. So constraints, there are 3. Okay. So here, let's take a look. So the constraint stuff is applied impulse type. Interesting. Applied force 2. Huh, I wonder what that is. Constraint, body 1, 2. Oh, that's the idea of the bodies that they're attached to. Applied torque, braking. Oh, you can break these. Okay. Which I think I saw a bit about that in the Dev Talk thing. Okay, applied torque and constraint frame. I'm assuming, yep, that's a matrix to make sure it fits into a certain place. Wow, that's a lot less, that's a lot less than I thought there would be. Okay, so if I were to... So this needs to be in between all of these, but so I'll put you in here. Let's do count, and let's just randomize all of this. So random body 1, body 2, let's just randomize all of it and see what happens. Oh, oh no, oh no. What's going on here? Let's take a look. Okay, so some things are being bound. Interesting. How many of these do... Oh, okay, so just 10. Okay, we're in the clear still. How many cubes do we have? We have 150, so let's do... Yeah, 110. So here we can see that quite a few of those are trying to be constrained to each other. That is very funny. Let me go and turn off the torque. Oh, whoops, it crashed. Sorry everyone, that's it for today. Thank you all for watching. I hope you all have enjoyed seeing a look into the future of Geometry Node, potentially. Again, experimental branches appear all the time, and, you know, they come and go. But, yeah, it's cool to see what a possible future of Geometry Nodes is looking like. Thank you all for watching. I will see you all next time. Have a good night.